Okay, question 3.5. Consider the following code segment, and they give us some code, some things to sort of recognize they're really just looking at that code, and they say explain in your own words what this code is doing, in other words, what its overall purpose is. Okay, importantly, and that's why they're stressing own words, please don't do a Delphi to English translation where you say, okay, in the first line it says I count equals 0, and in the second line it says for loop equals 1 to whatever it happens to be, and okay, that's not telling us what the code is doing. So in other words, your answer in fact won't refer to any Delphi directly. You'll obviously interpret the Delphi while you're formulating your answer, so that's what we need to do. Okay, I count equals to 0, that's fine, so we're obviously going to count something, and that's become standard. That's going from 1 to the length of the string, whatever it happens to be. Okay, so let's assume we had, and again, often helps to have a sort of idea of a string in mind, so I'm just going to create a sort of one with, I see, because they are looks like they might be testing for some vowels down there, so I'll get a mixture of vowels and non-vowels. There we go, and some other things. Okay, so just in case we don't see it straight away, we can always say, okay, or if we do see it straight away, we can test it and say, okay, yes, no, that's right. Whatever I've thought it looks right, because I've tested it against this. Right, so this is testing for each character in the loop, and it's testing against the lowercase vowels A, E, I, and O, and U, not old MacDonald's E, I, E, I, O. Okay, just the lowercase vowels. Okay, but this is critical. This is critical here, equal to 0. Okay, so what we've got there is something interesting, because normally we're used to that being tested as greater than 0. In other words, but this is testing equal to 0, the pos function. So it's saying if it's not in there. Okay, so if it's not in A, E, I, O, U, then increment the count. In other words, if we look at our string, the only characters that will, only time count will be incremented if the character is not a lowercase thing. So in other words, for the capital A, for the capital E, for the B, the N, the P, the 1, and the 2. Okay, so that's when it will be incremented, when it's not a lowercase, and that all revolved around that being equal to 0. Right, we've ascertained that that code is counting, well, count will be incremented every time the character is not a lowercase. So in other words, every character except lowercase vowels are being counted. They say rewrite the if statement without using the pos function. And remember, we've said all along there's basically two ways when we're testing. We can sometimes use the pos, we can sometimes use the ins, we can often use both, as is the case here. So we're testing here, but remember, this is testing if it's not, if it would be so easy just to change this. Let's assume that that was greater than 0. In other words, we were testing. Then it would be very easy to change this, and we could just say if s new loop in, okay, and then we would just create a little set over here, and we would create that set. Right, I've just magically created that set there while you weren't looking, and so that would be the set of values, but that would be testing if it is AEI. We wouldn't test if it's not. Okay, now we can't possibly list all the possible characters that it can't be, because it could be symbols, it could be all sorts of things. So how do I fix that up? Because now that's testing if it is, I want to test if it's not one of those. Okay, we can use something we don't use that frequently, is the not operator. We can say if not, in other words, reverses that. Okay, so it has a round bracket there, so we're just adding this part here and another bracket. In other words, if it's not in there. Okay, be careful you don't sort of say if this in, okay, it's not. In other words, it reverses it the other way around. So it's an unusual way of writing it, but it's based on the principle that if it's not false is true and not true is false, if that makes sense. So that would be, oops, there's, I've taken that square bracket out for that set there. There we go. Okay, so that would be able to rewrite it without the use of the pos function. Okay, if it was testing, if it was in that set, then I would just simply take the not off and the brackets away. I wouldn't need them. Question 3.6. Coders need to take the first character in the string and move it to the back of the string. So if string 1 was A, B, C, D, E, okay, then that A is got to go to the back. Okay, that A is got to go to the back. Okay, so essentially it's a move operation. So we've got to get it to the back. Explain the 2 reasons. Okay, so they tell us the 2 reasons why the following code will not work and how to correct it. Okay, well, let's have a look at it and practice this code in our example. Okay, here's a delete function up first. It says delete from string 1 the first character. Okay, now that's creating a problem straight away. Okay, because now that that's gone, how do I copy it to the back of the string? It's just disappeared. Okay, so that's obviously a problem. Okay, so what I would think is that it needs to be added at the back. So I'm guessing, and this looks like it's trying to swap it to the back. So the first thing, so essentially what we need to do is copy this to the back first of all, not delete it. Okay, so you might say, but now you've got 2 A's. Then you can delete the first character, because we don't want the thing to be cloned, okay, and have a copy of itself. Okay, so maybe those statements need to be switched around. Not maybe, in fact, they do need to be switched around. So let's try that first, and then let's look at our code to see if that makes any sense. I'm guessing it doesn't, because they've told us that too. Okay, so this first one needs to copy the A to the back of the string. Okay, so it says create string 1 by taking the first character, which is the A, and adding on the rest of the string. No, but that's not going to, no, because then I'm going to end up with this. That's not what I want. I want that A to be at the back. Okay, so this needs to be swapped around as well. So this needs to be, in other words, take the current value of the string, the whole entire string, and add the first character on so that it goes at the end. In other words, if it was A, B, C, D, E, it would now A, B, C, D, E, and the A would have been copied to the back. Okay, the A would have been copied to the back, which is fine. And the next step will sort out the original one at the beginning, and we'll just delete that first character off. So again, another example where is run your logic against the example. Okay, and if the example is not given, try and come up with one. Okay, 3.71, they ask you in all these questions to consider the following code segments and explain in your own words what the code is doing, in other words, what its overall purpose is. Again, like we said a little bit earlier, please don't just translate it and say, in other words, to use Delphilish or Delphi English, I count equals 0. Okay, then the next line says go from loop to length, and then the next line says if. That's not telling us what we're doing. It is to say your final answer probably won't reference the Delphi at all in the answer, but obviously in formulating that answer you're obviously going to have to do it. So okay, so I count is equal to 0, so I'm guessing, and there's an increment count, so something's been counted in here for some reason. So let's have a look at this. Okay, that's standard. That's going through the number of characters. It's going through each character in the string. That's standard. That we've got used to. So that text there is so standard because that just says go through the whole thing. So stext is the whole string. Stext square brackets I loop are the individual characters, because it's going to go from 1 to the length. Okay, however many characters. And the testing that it's doing, it's testing if those characters are in 0 to 9. In other words, are they digits? Okay, so 0 to 9 meaning 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then increment the count. So effectively what it's doing, that part there in total there is counting how many of those characters are digits in that string. Okay, it doesn't matter if it's a letter or something that is not counted, or a special character. Okay, so that's what we're saying is now that's the purpose of that code. The purpose of that for loop in part is to say count how many digits there are in the string. The next part does a calculation that says take the number of digits and divide it by the length of the string and times by 100. Okay, just looking at that divide and times by 100, immediately percentages flashing into my mind. And if we think about it, that makes sense, because that's the number of digits. That's the total number of digits. sorry, that's the total length of the string. Sorry, that's the total length of the string. So if there are 10 characters and 4 of them are digits, then 4 divided by 10 times 100, 40% of them are digits. So that's effectively calculating what percentage the number of digits is in terms of as a percentage of the length of the string. And then there's a show message in a float to string format, so they obviously want it formatted, so they're formatting it to 1 decimal place. Okay, so effectively what we're ending up here with is they're calculating and displaying the percentage of digits in the string to 1 decimal place. Okay. So again, this question you can see now can be asked both ways. You could say, write some code to calculate the number of digits in the string. Now add some more code to work out what percentage this represents the string, and then you would write the code. Now we're just doing it the other way, and we're saying, right, here's the code, interpret what it's doing. Well, 372, again, we're having to decide what's happening here again. And you can see that's this sort of fairly standard pattern. Okay, there's an S new being initialized, so I'm assuming we're going to assign something to it. And yes, it does happen a little bit later on. But the standard, let's go through the whole string. Let's look at each character. And based on that, let's decide what to do. Okay, sorry, jumping around there. Okay, if it's in A to Z, uppercase or lowercase, in other words, if it's an alphabetical character, then add it on to the new string. So that's the character. We're testing if it's alphabetical. So only alphabetical characters would be added on to that new string, irrespective whether, so in other words, the A would be added on, the B would be added on, the 1 wouldn't, the 2 wouldn't, the small w would, and the hash sign wouldn't. Okay, so effectively what we're saying is it's creating a new string by adding on the alphabetic means uppercase or lowercase from the string. In other words, or if we said it's removing any non-letters would be another way of putting it there as well. Okay, we'll move on to 373.